Thank you very much, Sarita, for giving me an opportunity to talk to you guys. Living Science is doing a wonderful job of connecting with students who are interested in a career in science, and so it's very nice for me. It's an opportunity for me to talk about my experiences and also share some of my thoughts on AI. AI is my area of research, and you may have heard a lot about it, so I think it is going to be very timely. I'm going to talk about the past and where we are today and how the future is looking for us. Before I start, I should mention that my wife is also in the audience, and I'm rather nervous because this is the first time she's hearing my talk. So we'll see how it changes the discourse in family conversations later, but we'll see. Okay, so let's get started. I hope all of you have heard about AI, but many of you may not have heard about AI in a technical course. You may have heard about AI from popular media. In conversation like this, that conscious killer robots are going to enslave all the humans, or that this is a very weird headline that I saw. It almost feels like not a news article but a story for a Hollywood movie. Or somebody actually wrote a very interesting article saying that suppose AI becomes our overlord, and AI should read this article so that it will find some reasons not to kill all humans. And Elon Musk obviously says that AI could doom human civilization, and so does Stephen Hawking. So what's going on? And there are some sane voices there in the middle which also bring out the point that Elon Musk is wrong, the AI is not going to kill us all, and in particular this particular survey of 50 Nobel laureates, and they are Nobel Prize winners, they probably know their stuff, have ranked climate, population rise, disease, and even Trump as bigger threats to humanity than AI. So this is one kind of discourse. The discourse is that AI is going to completely kill humans maybe a few years down the line. Okay. There is another kind of discourse which is at least a little bit closer to reality, or some part of reality, that someday it is possible that some of the robots are going to take some of our jobs. And of course, different people think of it at different levels of extremes. So this one particular article says that the world is going to sink into a hellish dystopia, right? Of course, there are people who contradict this, saying that no, many jobs are safe from AI, but some people believe that many kinds of jobs might be eliminated at some point. Of course, at the same time, while some jobs may be eliminated, it will also create many more jobs, or it will at least this believes that it will create more jobs than it will eliminate, and it will create definitely new and unconventional career paths. So the world is evolving around us. The world is evolving somewhat rapidly right now, and I think it is important for all of us, irrespective of whether we are computer scientists or whether we are scientists or not, to really understand what is going on. What is AI? Why is there so much hullabaloo about it? What is its history? Where are we? And where is it going? And how does it affect us? So this talk is a talk meant to give my perspective on the issue, and this is what I'm going to do. I'm going to first start with really basics. This is sort of what I start teaching in my first class, in my first AI class. What is AI, right? It's actually a concept that people within AI also debate about very often. It's a philosophical issue. We'll talk a little bit about it, and then I'll explain how AI has come to this point. What happened in the history, how AI evolved, what were the various salient events that led us to today, and where are we, right? Where have we reached, and where are we going, and how it's going to affect us, right? So let's get started. AI stands for artificial intelligence. The artificial part is relatively easy. We as humans are natural, and machine or table or anything like that is artificial. So the major question is, what does it mean for a machine, right, to be intelligent? That would be artificial intelligence. To understand that, we should ask the question, what is intelligence, right? And again, if you go to articles talking about what is intelligence, people debate this all the time. Philosophers disagree with each other, psychologists disagree with each other, people believe in and do not believe in IQ tests, people devise new tests. So it's actually by itself a complicated question. So if you go to dictionary, that definition also doesn't really help you. So for example, this is the dictionary.com definition. Intelligence is the capacity for learning, reasoning, understanding, and similar forms of mental activity. So, in some sense dictionary.com lists various things that could be considered intelligent, like learning and reasoning and understanding, but it gives us a hint of what else could be intelligence, basically forms of mental activity. Now, this is not surprising, because since ad infinitum humans have believed who is intelligent? Humans are intelligent. Intelligence has been synonymously associated with humans. So, therefore, it is not surprising that we would consider intelligence as some form of mental activity. But since we are making machines intelligent, we need to ask this question: are humans intelligent, or are humans always intelligent? Do we not find some humans which we would not necessarily call intelligent? But at least from an AI point of view, since humans were always considered intelligent, replicating human behavior was an early hallmark of intelligence. If we could make a machine that does how humans do, we might call it artificially intelligent, right? Of course, humans are not always intelligent. We do not want to replicate all kinds of human behaviors. We know that humans are prone to jumping off the cliffs and hurting people and committing suicides and all of that, or feeling very angry in various circumstances. We do not want to build machines which feel the same way, right? So, we all have shown our anger on Microsoft products once in a while, but if Microsoft showed its anger back, you will stop using it right away, right? So, we need to also ask the question, can non-human behavior be intelligent? Are we going to limit ourselves to the behavior that humans have, or are we going to go beyond it or going to do something else? With this context, lots of people thought about different definitions of artificial intelligence. And if you look at the traditional textbooks on AI, and here I am showing you 4 different books which are all defining AI in very different ways. And in fact, if we can summarize them, we can put them on a 2 by 2 grid like this, and this is the simpler forms of those definitions. An AI is a system that thinks like humans, or that acts like humans. So, this is the human column, or that thinks rationally or that acts rationally, that is the rationality column. Now, we need to figure out which one do we like. Do we like human like, or do we like rational? And similarly, do we want to build systems that only think, or do we want to build systems that act? And over time, people debated these definitions. For example, when you think about building a system which thinks like humans, it becomes a really hard task. How do you know how you think? Do you know how you think? Do you know what processes happen in your brain that allow you to think in a certain way? And definitely it is not clear that when we are making a certain decision, we may be just making that decision emotionally, and then when you are asked how did you make this decision, then we come up with some post facto rationalization. We do not want to build machines that take emotional decisions and then create some logic for why they took certain decisions. Similarly, systems that act like humans, that is actually a really interesting thought right there. In fact, this was the definition that Alan Turing provided very early on. Way back in 1950, when he thought about building machines, computers had just come up at that time, the World War had just ended. He thought about, can the machines think? And if the machines can think, how would I know? How can I know that somebody thinks? Forget a machine. The only way I can know that they think is by asking them questions, is by communicating with them, is by seeing how they act in the world, and then making a judgment on whether they are intelligent or not. Suppose I claimed that this table thinks. It is making some deductions inside in its wooden brain. It is proving a theorem. Can I ever know that this machine thinks, or this table thinks? I would never know that this table thinks, because the table has no way to communicate to us what it is thinking. Until you start to communicate to the world, until you start to act in the world, even if you are intelligent, it will be very hard for us to assess it. And therefore, in terms of a pragmatic operational definition of AI, just thought was not a very good idea. It was important to act. And there Alan Turing said, well, how would I know that a machine thinks? I would do an experiment. This experiment, there will be a screen, and you would be communicating with something behind the screen, and the screen would be giving answers. And if we believe that the thing that we are interacting with behind the screen is a human and it turns out to be a machine, then I would know that the machine has reached human capabilities and therefore it is acting like humans and therefore it is intelligent. And this is the very famous Turing test that he devised. Of course, there are some issues with that test. First of all, just mimicking humans does not lead us very far. Humans, obviously, as we discussed, are not always intelligent, and moreover this kind of test is not reproducible and so on. So, therefore, later people went into rational thought as well as rational behavior, and as we discussed, thought itself is not enough. So, eventually the definition of artificial intelligence became synonymous with systems that can act rationally. This had all the right properties. We were not bound to be mimicking human behavior, and we were not limited to just thinking. We wanted to have rational actions, and most likely if you are taking a good action, you are probably having a good thought process underneath that would lead to that particular action. So, that satisfied a lot of us, but I will still say that still there are many people who work in various aspects of AI, and different aspects of AI fall under different brackets, and they are all fine, they are all various parts of the same puzzle. But now that I have delegated the definition of AI to acting rationally, the natural next question is, what does acting rationally mean? What is rationality? How would I define it? Because we are defining a field, it is important to define it technically and formally, right. Now, rationality by itself intuitively means doing the right thing. I am given a situation, the situation may be complicated, my actions may have implications, but I will still end up doing the right thing, right there. But how do I define right? What is right? Right? And in fact, for different people, right varies a lot. And if we are defining AI, we need to define AI which can work for different kinds of people, different kinds of scenario, and different definitions of right. And therefore, it was the ideal rational agent that we are trying to build in AI is first given a performance measure. This performance measure is something that I want to optimize. It is my objective function. We as humans also have objective functions. We put some value to money, we put some value to love, we put some value to family, we put some value to lots of these different things, and their complex combination gives us an objective function. This is called our value system. We all have slightly different value systems, but we are all trying to, and it may change, but we are all trying to optimize it. Similarly, the machine needs to be given an optimization function that it wants to optimize. Okay? As we said, we are going to act rationally, so it is allowed to take an action. Now, what is it allowed to take an action based on? It is allowed to take an action based on what it has seen so far. So, it has seen some observations in the world, this is yellow, and if I drop an object, the object falls down, and many other things. So, I have some understanding of how the world has evolved to where I am. I have some built-in knowledge that about gravity or whatever it is, and based on that I need to figure out which is the best action to take. It is important to realize that when the intelligent rational agent decides to take an action, it does not know the future, it only knows the past. So, it makes the decision based on its past and based on some expectation of what is going to happen in the future. How many times in our worlds does it happen that we took an action, we made a decision, and maybe an hour later or a day later or a month later or 10 years later we decided that, oh, that was not a good action. We are not being intelligent when we say that that was not a good action, because at the time of making the action, we have a power of foresight, we do not have the power of hindsight. We do not know what is going to happen. It is possible we took the right decision, just the probabilities worked out against us. So, that does not mean that we did not take the right action. We only need to decide what action to take. An intelligent decision maker will decide what action to take based on what it has seen so far, not what is exactly going to happen in the future, right. So, therefore, the agent does not need to be omniscient, it needs to know whatever it knows, right. Of course, it can act in order to know more information, but it is supposed to make the best decision based on what it knows so far. right? And this is very important. So, think about babies. Suppose I have a 3-year-old who can do who is just taught addition of 1-digit numbers and who can somehow figure out addition of 2-digit numbers. We will call this 3-year-old extremely intelligent, right? On the other hand, if there is a 20-year-old who is taking computer science in some school and that person can do 2-digit addition, we would not call that person intelligent. So, therefore, intelligence is not absolute. It is dependent on what knowledge the agent has ahead of time. In this particular case, if I give you the algorithm of addition, then figuring it out is not intelligent, you are just running the algorithm. On the other hand, if you did not have the algorithm for addition and you figured it out for the first time, that would be called intelligent. Same is true for theorem proving. Suppose you did not know a theorem, it was a conjecture and you proved it for the first time, yes, that is very intelligent behavior. Once you have proved it, you have memorized it, then you are repeating the proof, that is not necessarily very intelligent. So, intelligence is a function of what knowledge we already have. If I already have the answer somewhere stored, then that may not be called intelligence. However, if I have been given relatively limited knowledge and then I am able to figure it out, then it is called intelligence, right. So, there are all these factors that go into designing an artificial intelligence and an AI agent. So, again, just to summarize, an agent is acting in some environment. The agent gets a sequence of observations through its sensors. You and I also do that. Our sensors are eyes, ears, and a machine may also have its sensors. It could be laser rangefinder for a self-driving car, for example. So, it senses information from the environment, then it does lot of reasoning. It thinks about what the world is now, what do I know about the world, what do I already know about the world, what is my built-in knowledge, what do I make my predictions based on, do I know how the world evolves, if I do not, I learn that, if I know how the world evolves, I think about what happens if I take this action, how will the world change, and based on that I will figure out how happy would I be. This happiness is the optimization function, and then I will pick that particular action that maximizes my reward, my optimization function, and that leads me to taking the action that I need to then take. And all this process happens within the brain of the AI agent, right, and that is the AI system that we are trying to build. Now, this shows up in a, so as you can see, the definition of AI is fairly high level, fairly philosophical. So, it shows up in a wide variety of scenarios, like it could show up in formal cognitive tasks, right. These are tasks that you and I probably will call intelligence tasks, like playing chess. You know, we have believed that playing chess is a hallmark of intelligence, or playing other games like that. Being able to do mathematical logic, or being able to do geometry, or being able to do calculus or complicated questions, right, theorem proving, all these are formal tasks that require a lot of reasoning, and those come under AI. At the same time, there are some tasks which require expert knowledge, right, like engineering design or medical diagnosis or financial stock market predictions. Because AI agent allows you to have built-in knowledge, you can put in knowledge about how stocks evolve over time, or how different diseases show up as different symptoms, and then you can build a reasoning system on top of it which will do medical diagnosis for you. So, that is also part of AI. And then there are some perceptual tasks, very simple tasks for you and me, but very difficult tasks for machines, like vision. Vision here would be understanding scenes in images or in videos, or speech understanding. You can understand what I am saying very easily, but machines may not always find it easy. So, just this perception tasks, right, the tasks that come very naturally to us, those kinds of tasks are also part of the AI system, because you can always define an objective function like identifying the right object in the image, or identifying the right words spoken by the human, and then I want to optimize that particular objective function, right. So, this is a fairly broad definition of AI, and as you can see, AI can show up in wide variety of scenarios. So, now let us go and think about how AI evolved. I have already talked a little bit about Alan Turing, right. Alan Turing, you may all know. Alan Turing is the person on whose name we have instituted the Turing Award, which is equivalent to the Nobel Prize for Computer Science. And in 1950, when he started to think about the question, can machines think, he thought about how would I know when they think, and that led to figuring out his designing the Turing test in his 1950 paper. But at that time the word AI was not coined. The word AI was coined by John McCarthy, who is at the top here. He is one of the 4 founding fathers of artificial intelligence. As this narrative had started to see whether machines can think, they wrote a Dartmouth AI project proposal, where they proposed that a 2-month 10-man study of artificial intelligence be carried out during the summer of 1956 at Dartmouth College, and their hope was that in 2 months they would figure out how to build AI. Now, you may realize this or not, but AI researchers have often been dreamers. Often, things that you see in science fiction movies, they want to make it a reality. And this has happened many times. They want to think about how the future is going to look like. They are very optimist in life. They can do lots of things, or they believe they can do lots of things. And so here, the next 2 that you see, who are the founding fathers, Alan Newell and Herbert Simon, they were in CMU, and they were creating this program called the Logic Theorist, and there the goal was that all the theorems that Bertrand Russell has written in his Principia Mathematica, they will build a theorem prover that will prove all of them. They thought that intelligence will be exhibited by proving theorems, and they wanted to build a program that can prove all the theorems in the world. And then the last is Marvin Minsky, who was at MIT, and he is my great-great-grandfather, academic grandfather, and he and along with the other 3 built came together and designed this project proposal, and they got together and the field of AI was born. And they had very high hopes. They were sure that within a very few years they will be able to build a chess playing program that will defeat humans and the grandmasters and so on and so forth. And there was a lot of excitement early on, right. This is a very brief and incomplete history where some early industrial robots got created and General Motors actually started using them. Eliza came about, which was like a chat bot which would talk to you and it became like your psychotherapist, and then Shaky came out, which was sort of the first electronic person which would do general purpose mobile robotics and can do lots of things for you. So lots of things were happening, too much was happening. People were claiming that chess will be done and robots will take over the world and so on and so forth way back in the 60s. So imagine the state of computing technology and hardware at that time, and they had these kinds of dreams. So what was going to happen? Obviously failure, right. When you start making unreasonable claims about what you can achieve and then don't achieve it, then it leads to some kind of reduced excitement in the field. And so in 1966 came the failure of machine translation, or not failure, but a report that said that machine translation is too hard, and slowly neural networks, which was one of the popular formalism, got abandoned because of some theoretical results, and many things started happening. And by late 60s, early 70s, we were in what is called the AI winter. This is the first AI winter. Basically, the point was that AI researchers are claiming a lot of things but can't achieve it. Then things started improving back in late 70s, early 80s, but then again in late 80s there was a second AI winter, right. And so what happened is that there were these hype cycles. There would be a lot of excitement about AI, a lot of funding would come in, defense will put in funding, and then at some point people will realize that, oh, the problem is too hard, not going to be possible, and the whole cycle goes down, right. The funding reduces, people stop going to conferences. I am told that one of the top conferences had about 5,000 people one year, and next year they had only 800 something people, because suddenly all the people who were there because they thought AI can solve their problems were gone, because the AI winter had started and the bubble had burst in some sense, right. The point I want to make here is that AI is used to this hype. These things happen all the time in the world of an AI researcher. In fact, the last time this bubble burst, the winter came, there were some researchers who are still alive. So I will come back to that. They keep giving us a word of caution these days. Now we are no longer living in an AI winter. Of course, right after mid 90s, the AI winter had sort of warmed up a little bit, and AI had started becoming better, but it had lasting effects. So even in 2007, in an Economist, someone wrote that artificial intelligence is associated with systems that have all too often failed to live up to their promises. This is where in 2007, this is when winter has already ended. Or some people, somebody wrote in Pittsburgh Business Times that some believe that word robotics actually carries a stigma that can cause hurt a company's chances at funding. And I saw this firsthand because I had completed my undergrad from IIT, and then I went to US and started working in AI. I was very excited about it. This is early 2000s, and I came back, and my professors asked me, so what do you work on? And I told them, I work in AI, and they gave me this smile. AI, okay. And this happened to me 3 or 4 times. So at some point, one of my professors asked me, so what do you do in AI? So I told them, oh, I am using Markov decision processes and this and that. And he said, oh, so why are you saying you are doing AI? Say you are doing operations research, then it's all fine. Yeah, as long as you are doing OR, it's okay, but don't say AI. And so then I realized I was somewhat historically weak in history. So I realized that they all got trained in AI in their 80s and early 90s. And so to them, AI resembled a technology that never worked. And of course, times have changed, and we will come to that. Okay. So now, how did things start changing? So I told you about until 1996, we are in this AI winter, or second AI winter, and the first real success happens. And the first real success happened when this program proved that Robin's algebras are all Boolean. Now, the details of the exact proof and the exact theorem are not important. What is important is A, this was just a conjecture and was not proven, and the proof was not known to mankind until an AI program actually proved this. And second, what was really interesting is that New York Times in 1996 wrote a very interesting article where it said that this program has come up with a major mathematical proof that would have been called creative if a human had thought of it. So notice how conservative the narrative is, how difficult it is for the writer to say that it is a creative proof that the machine came up with, because creativity can't be for machines. So therefore, the best they would say is that it would have been called creative if a human had thought of it, right. Now things started to evolve from there, and the major development happened, which I think most of all of you might be aware of, is that Deep Blue defeated Garry Kasparov. Deep Blue was a chess program that was built by IBM. A huge supercomputer powered this program, and Garry Kasparov, after this game, said that I could feel human level intelligence across the room. Now there is some history, because Kasparov had also competed against earlier versions of Deep Blue and had won. So the computer programs had been dismissed, but finally the first time computer program won the full match. It won 3.5 to 2.5. Now of course, now we all understand that in chess the machines are much better than humans, and there is no point competing against machines if you are a chess player. This is now well understood, right. And as it says, in a few years, even a single victory in a long series of games would be considered triumph of human genius, because the machines have figured this out much better than humans. Now that led to a very interesting narrative right there. So the question that was asked is, does Deep Blue use AI? See, at the core of it, it was some technology, right. In this particular case, it was minimax search, which is some kind of heuristic search with some very sophisticated heuristic functions and rules and so on and so forth. Would you call this AI? And a lot of people said, no, this is not AI, this is just minimax search. It is this algorithm, it is not AI. This is a goal post that we can't reach. If we reach there, we would call it intelligence. Think about intelligent doors. Let us go back 100 years. Suppose think about a science fiction novel writer who is saying, can we build intelligent doors that come open by themselves if I walk and I want to go past? Wouldn't that be an intelligent door? Now we know that is not intelligence door, that is just called mobile sensor or movement sensor. Once you put that sensor and a motor there, as soon as it senses somebody is coming, the door would open. There is no magic there, there is no intelligence there, it is just that sensor which is leading us to that feeling. So, therefore, in the very same way, I want to reach there, that is my goal post, that is what I would call intelligence. The process of reaching there is hard, but once I reach there, after the initial excitement, I have reached there with a certain algorithm, an algorithm that I understand how it is working, and now I know how to achieve that, and that does not feel intelligent anymore. It is just that one algorithm, the mystery, the magic has now lost, and the next thing that I cannot reach, that starts to look like intelligence. And so, therefore, with every success that AI had, the natural reaction was, this is not AI, this is algorithm X or algorithm Y, and therefore, later the AI researchers started to believe that whatever they can do, they will never be able to satisfy anybody that it is AI. Whenever it starts to work, it ceases to be AI and the next thing is AI. So, there was this very natural, we started believing it, if it works, it is not AI, right. So far so good, I will come back to this point at some point. Things evolved, and in 2005, we had a very interesting victory, or we, when I say AI researchers, had a very interesting success. DARPA, which is the defense agency in the United States, put together this challenge where all these cars would have to cross the Mojave Desert. It is in Nevada, it was a very complicated terrain, and we did not believe that the cars can do it by themselves, but 4 cars completed this whole stretch. This is a 132 mile mountain road. That was a huge victory, and of course, we all know where that has led to. It has led to self driving cars, which are very popular in the US, and it is now coming, that technology is coming in, just user cars, and Uber is using it, and so on and so forth. Another very interesting technology success happened in the context of text processing and language processing, natural language processing, where the Jeopardy game was won against the all time major Jeopardy winner, and it was won by IBM's Watson program, right. And Ken Jennings pledges obeisance to the next new computer overlords. There is one very interesting future thing that I wanted to show, where RoboCup, where people believe that someday they want to beat Brazil in soccer. And so, this is the state of RoboCup circa 2017, that is last year, and you can see that we are very far away in beating Brazil. In fact, you will see now that we are rather far away. So, whenever you feel that robots are going to take over the world, do not forget where we are in terms of, but this is a very huge skill, the ability to stand by yourself. This is actually not very easy, and children find it really hard also, and see how finally you can achieve goals, right. That is a goal, and that is a goal too. So, so this is where we are, this is the history. This is where I would say we were maybe except the last slide, this is where we were about till 2012. Okay. So, what has changed? Now, things have changed, because by then we were not getting that many newspaper stories about AI, nobody was saying that AI can do anything, people believed that AI does not achieve anything, if it works it is definitely not AI, and suddenly things changed. Suddenly, I mean in the course of 2 to 3 years things started changing. AI stopped becoming a bad word. This is the number of transcripts that mention artificial intelligence from industry point of view, and notice the exponential growth. Obama said that my successor will govern a country being transformed by AI. So, something has happened, something rather revolutionary has happened. And what has happened is that 3 roads which were sort of happening in parallel have suddenly met, or happening independently, which were moving independently, not in parallel, they can't meet, but they were moving independently, they have suddenly met. What are these 3 roads? So, one road is the road of algorithms in AI, right, that has been happening since 56, as we have discussed. The other thing is, the other road is the road of increasing computation power. We have better and better machines and stronger GPUs and many such units, which have increased regular researchers and engineers ability to process information rather rapidly. And the third thing that happened is that new and interesting and large data sets started getting created. And when all of these things came together, that suddenly led to a revolution which was more or less powered by a technology that we call deep learning. Neural networks is the basis of that technology, and neural networks have been around since the maybe 50s or 60s. The idea is that as our brain is composed of neurons and connections between neurons, we will have machines and algorithms and models which will be composed of machine neurons, and they can send signals to each other, and that can be trained to reach a desired objective function. Now, this technology has been around for a long time. Even the deep learning technology, most of it has been around since 90s, late 90s. But suddenly when it met the ability to process lots of data and do long term training, and having lot of data which can be used to train these systems, suddenly very exciting results started happening. So, one of the most important and the first success that happened was in the context of object recognition. There was a huge data set that got created, which is called the ImageNet data set, which has lots of images and associated objects that are in the image. And if you go back to 2011, when people were solving this problem without neural solutions, without neural networks, the accuracy was about 75% with an error about 25%. This is 2011. And by 2015, in 4 years, the error went from 25% to 3.6%. And this happened basically by using neural networks. AlexNet was the first. It was an 8-layer neural network, had accuracy error of 16. Then came ZFNet, VGGNet. Google had its network that created about 7% error, and then Microsoft produced a residual network. And notice the number of layers are becoming deeper and deeper and deeper. It's a deepening war. So, as our machines, as our brains have many layers of neurons, in the very same way these neural networks have many layers in its network. And so, we have gone to 152 layers which are trained over maybe a month or something on a very, very large cluster, and so on and so forth. But now it has surpassed human performance, because human performance is about 5% here. Many exciting new applications started coming. You give me a doodle, I will give you an image. Or not an image, you give me a doodle, I give you a painting. You give me a style and an image, and I will combine the two to produce an image which will be the original image in a style of the first image. You give me a black and white image, I will color that for you automatically. All these and many more, and not only in vision, but in combination of vision and text, for example. So, for example, if you give me as in the machine, a deep learning system, an image, it may produce a caption automatically. So, it produces a caption, a person riding motorcycle on a dirt road. This was unthinkable in the pre-neural network era. A group of young people playing a game of frisbee. Look how tiny the frisbee is and how the machine is able to figure out that that's a game of frisbee going on. Of course, it's not always correct. For example, it believes that there are 2 dogs playing in grass and not 3, or it believes that the hockey players are fighting over a puck where they are not, they are playing their own piece, or there is a skateboarder, but there is no skateboarder here, there is a cyclist. So, it does make mistakes, but the fact that we can do even this or even this is just inconceivable, was just inconceivable a few years ago. And this has all happened due to the usage of neural networks, deep learning. Not only in vision and text, it has gone to speech recognition, where this is the automatic speech recognition accuracy from the 70s, and notice we are in the 50s and 55 and 60, 62, suddenly we have hit 95% very soon. This kind of an exponential growth has now changed the landscape in voice based assistants. Now we have Siri and Alexa and so many of these where we can build queries, and that is changing the user behavior, because in addition to keyword searches which we did all the time, we can now do voice searches, and their fraction is increasing and is projected to surpass the keyword searches as we have these assistants that we have access to. While all this success was in perceptual tasks, there were other success in decision making that was happening. For example, AlphaGo is a software by DeepMind which defeated Roger Federer of Go, Lee Sedol. And Go is a much harder game than chess, right? 1996 we defeated chess, we thought that's good, but Go was so hard that for every time I used to teach my class, I would say there are 10 years, we are 10 years away from defeating in the game of Go. And then suddenly the next year we defeated, we as in machines defeated humans. And I remember that my collaborator and I had a bet going, and I was putting my money on not winning, and I lost. But the signs were already there, because this was not an off case. They had trained one neural network architecture on a variety of Atari games. If you are old enough to remember what Atari games used to be, they found that this one architecture that they created could reach human level performance in so many of these games in one go. And then of course, there were some games that were still waiting to be solved, but their model had already started showing lots of value. So, this new model, deep learning model, has a lot of technical strengths. First of all, it is a powerful representation. It can represent any kind of function. You do not need hand coded features, and that is actually a very important point, because humans do not know how we see. So, when we have to code features about how to recognize there is a face in here or there is a ball in here, we create some features which are sort of incomplete and not effective enough. But now with the new technology, we do not need to give those features, they are induced in a task specific way by end-to-end training. And moreover, this is one universal representation that works across modalities, like it works for text, it works for vision, it works for speech, it works for decision making. So now when we want to have integrated systems where these technologies come together in building something bigger, it can be easily and seamlessly put together, whereas that was not possible in the olden times. Of course, it has some weaknesses. No technology is devoid of them. It is data hungry, it is compute hungry. You need so much data to train this, you need a lot of computation power. There are lots of parameters to tune, which makes the results hard to reproduce, and it operates on numbers and lots of these numbers, and it is very uninterpretable by humans. We do not know how this thing is working, we do not know how to debug it when it makes mistakes, we do not know how to understand what the model is doing. So, therefore, there are some challenges that we need to resolve. Let me end this part of my talk by just reminding you that we were in a world where if it worked, it was not AI, and we are now in a world that everything is AI. If my thermos keeps the hot or warm, somebody will start calling it AI, right? Why has that changed? That has changed because now this speech input, this vision input and so on and so forth, that is on our fingertips. We are all interacting with machines on a day-to-day basis where AI is in there, right. For example, earlier if AI beat Garry Kasparov, then only the chess players will interact with that kind of AI. Those were like cognitive tasks. But now these are perceptual tasks. Because of that, AI suddenly has an ear and a mouth. You can talk to AI, everybody can talk to AI. So, it is there in direct contact with users, that is creating a buzz. Moreover, even AI researchers do not exactly know how it works. They design some neural network and then train it, and once it trains, it does these magical things, and you do not know how exactly the neural network is making that decision. So, that mystery of how the machine is doing it has remained. I do not know the real answer. As researchers, we do not know how machines are doing it, and that is why the magic still stays, right. And last but not the least, the speed of the progress has been amazingly fast, exponential, and so much hype because of the speed, the fact that people at large can use it, and also the fact that AI researchers themselves do not know how exactly things work. This combination has made AI to be such a positive word that now everybody wants to jump on the bandwagon. So, this is where we are. I hope this gives you a picture about where AI is in the current world. And now that begs the question, well, what about the future? Are we done? Is AI solved? Have we solved all our problems? And how is the future going to look like for us? Okay. So, in the very short next part of the talk, it is obviously a $1 million question, or maybe billion. I do not know how many dollar question this is now, because it is becoming bigger and bigger, and of course, I do not have all the answers. But I am going to give you a hint of how I think about this. So, first of all, these deep learning systems are effective, but not always. They are not very robust, and here are some examples from the object recognition world. So, if you give this image to a deep learning system, the first image, it will correctly predict that it is a panda, but its confidence would be, let us say, about 50-55%. Now, if you add this kind of noise, this is not random noise, it is well thought of noise, but if you add this kind of noise on top of this image, you get this image. Now, this third image also looks like a panda. To human eyes, there is not that much difference between the first image and the third image, but for some reason now the deep learning system thinks it is a gibbon and thinks this with a confidence of over 90%. This happens again and again and again. It knows it is a school bus, you add this noise, it thinks it is an ostrich. It thinks it is a dog, you add this noise, it thinks it is an ostrich. I do not know why the world is full of ostriches for the deep learning system or what. So, clearly there is a robustness issue here, and moreover it has a lot of data bias. So, it knows about 200 types of dogs, but does not know about some regular objects like flowers and books and so on. The other key challenge that we need to work on is human AI interaction, because slowly we are going to lead into a world where there will be lots of AI all around us, and we need to be able to communicate to it. For example, suppose I have a cleaner robot working in my home, then I need to tell this cleaner robot that I want to clean the dirt. So, I could say it in many different ways. Suppose I would say, you should not see any dirt. The cleaner robot will think, I should not see any dirt. To achieve this objective, let me close my eyes. That is a very valid way for the robot to achieve the objective function. I could say, have no dirt in the house, and the cleaner robot will say, the goal is not to have any dirt in the house, so let me throw whatever I have in the house outside. Now that I have thrown everything outside, there is no dirt in the house, I have achieved my objective function. So, I qualify, no, if you see any dirt, then clean that dirt. Okay, so the robot does its job, now there is no more dirt. It does not know how to increase its reward, so it just takes a vase and throws it on the floor. Now, the vase breaks, there is dirt. Now, it cleans it and it gets its reward. So, now you see that machines have a very crazy way of achieving their objective function, and we need to think very carefully about how we want to specify this. If we tell the robot you can't break things yourself, it will just make us topple so that we fall down, and in the process of falling down we break the vase so that it can clean the vase and get more reward, right. So, the machine will have to start understanding humans, and in the same way the human will have to start understanding the machine. The machine will have a complicated model based on which it is making some predictions. We will need some understanding of what is going on inside that model. We need these models to be interpretable and explainable, which we do not have right now with the neural networks. But if we are able to solve those problems, and I am very hopeful, as I said, AI researchers are optimists, I am very hopeful that this can be done. I hope that there will be lots of advances that we will be using all the time. These advances will increase our quality of life. We will definitely have fully autonomous vehicles in the first world countries. It is quite possible that if your child is born now in the US, they will never learn to drive. They will never need to. It is quite possible. We are going towards personalized healthcare. As we are collecting health data, we are trying to figure out which kind of medicine will be most appropriate for you. We will definitely have powerful personal agents like we have Siri and Cortana now. They will become much better. These machines could help people with accessibility needs. People who can't hear may have something where they can read what is being said. The people who can't move their limbs might be able to communicate with brain computer interfaces, and someday, not too soon, but someday robotics will get there, and we might have home robots, war robots, disaster management robots, and all kinds of robots, and lots of increased productivity. While this is going on, it is important for us to think about what does the future of jobs look like. Before future, let us think about the present. Do you know that 40% of companies struggle to hire and retain data scientists? A third of the top 400 companies lack state-of-the-art data analysis tools and personnel. 364,000 new jobs are getting created for data science and AI in general, and of those 50,000 are currently vacant in India. We have a severe shortage of data science and AI experts. So many jobs are going to be replaced, there is no question about it. Truck drivers in the US, they might not have a job, 15 years down the line. But lots of new jobs are going to be created. Definitely jobs about training an AI system, monitoring an AI system, working with an AI system, supervising an AI system, and so on and so forth are going to be created, and many more. We will have to retrain ourselves. In many ways, you can say that our jobs will not be replaced, they will be updated. They will reach a certain point, we will not have to do many mundane things that we need to do now. Of course, in the interim that might cause some disruption, but that always happens. That happens when industrial revolution came, a lot of jobs got swiped away, but then we have done fine as a society and mankind. But what I am definitely sure, or I am definitely as I can see it, that in the future we will have teams of AI and human intelligence. This happens today in chess. In chess, the best chess players are not human, the best chess players are not machines, the best chess players are a combination of AI and human intelligence. And the same is going to happen in many different walks of lives, because there will be some kinds of jobs which humans will continue to be better at, and some kind of jobs which AI systems will surpass humans on. So, I wanted to talk about this. This is sort of how the future looks to me. Before I finish, I want to delve a little bit, just 5 minutes, into the question of where are we in India in this context. Okay. Now, in terms of AI for India, I think the story is relatively clearer. Of course, West successes may not always apply. The Teslas that can work in and drive on the roads of US streets, I can bet you they cannot drive in the streets of India, right? With the cows and the cyclists and the crazy people who drive on the wrong side of the road, it requires something more than AI intelligence to be able to drive it, and even West drivers go crazy crossing the road, forget driving in India. So, we will not everything that works in other nations is going to work for us, but definitely lots of opportunities and possibilities for the use of AI in India. For example, in education, we all know that in tier 2, tier 3 cities, we have a real dearth of good teachers. Well, can AI augment them? Can AI understand each student much more carefully, understand where their knowledge holes are, provide information and feedback back to the parents and teachers so that they can be handled? I bet you we can do all of that. Smart cities can make use of AI. We have a huge push on smart cities. When should a light go green? When should it go red? Where should we have more development? What kind of development? When should we build roads? All of that can be done in a more data driven way. Microsoft already is starting to use technology in India where they give timely advice to the farmers about specific farming practices based on the weather conditions, water conditions. We know that in many villages we do not have good doctors. Sometimes people die just because doctors can't reach them in time. Can we use AI there to augment the doctors and make sure that the person is stable until the doctor shows up? There is a lot we can do in all these scenarios, and AI for developing world will have a lot of role to play. But I want to also talk about our neighbor, and often a country that we compare ourselves to, and how they are responding to the AI revolution. You may be surprised to know that the Chinese president in his New Year address had lots of books here, and 2 of those books were on AI. And one of those books was written by Pedro Domingos, who happens to be our own Parag Singla's advisor. And China and the amount of research it is doing in AI and the amount of push it is giving to AI is unbelievable. And slowly it is starting to surpass even the United States in its productivity at top venues in artificial intelligence. This graph shows the number of journal articles mentioning deep learning which have been cited, and China has already surpassed United States there. China has a huge push to become a world leader in AI by 2030, to be at par with the best very soon by 2020. That is their plan, and I think they are well on track, because AAAI and HCI are some of the top 2 conferences in artificial intelligence, and the highest number of papers as well accepted papers and highest number of submissions both came from China, and they surpassed United States this year. KDD is a top data mining and machine learning conference, and they run a competition, and last competition there were 2 tracks, and in each track they gave 3 awards, first, second, third, and all 6 of the awards were won by Chinese groups, Chinese teams. And this is a worldwide competition. Indians can participate, United States can participate, anybody can participate. China is putting in $2.1 billion for an AI industrial park, which will be 55 hectares huge. I read on reports that they are all getting AI researchers to come back to China. They have been doing this for a long time, but now it is sort of paying fruit, and the current salary offers are to the tune of $1 million per person for senior hires. This is for private companies. Now, when we think about this kind of revolution and this kind of push in China, it begs the question, where are we in India? And the story in comparison seems rather grim. Of course, we are doing very well for ourselves. We are improving better than we are much better than where we were. But there is a huge demand and we are just not meeting it. For example, there is 60% rise expected in jobs in AI in 2018, and we are not training enough students. We are paying a good salary in India. Our average salaries are about 1 crore per annum for somebody with 8 to 15 years experience. That's not bad, but when you compare this is $150,000 per year, and it doesn't match up to $1 million that Chinese top people might be getting, and it also doesn't match up to the high salaries that people are drawing in the US and elsewhere. So it does not give them financial incentive to move back to India. So they need to come back to India for other reasons, but financial is not one of them. Okay, and as we all know, many of these times capitalism actually becomes stronger than anything else. Think about research. We have about 30 researchers in the country who can be claimed to be publishing at top venues. Now that's not bad. Maybe 10 years ago we had 5, but neither are these 30 researchers publishing very regularly at top venues, nor is 30 a good enough number. We need maybe hundreds of them, if not thousands, in order to be at par with the world, but we are very, very far away. Our startups are doing fine. There's a lot of startups in AI space. Whenever I talk to a company, there's a lot of talk about AI and chatbots and this, that and the other. But if you do the numbers, do the arithmetic, you find that over 3.5 years from 2014 to mid of 2017, the total amount of financial investment that happened in Indian startups was to the tune of $100 million. Not bad, but when you compare it against Andrew Ng's recently launched private VC fund, it itself has $150 million. And this graph particularly shows you the amount of funding that is coming in for different countries, and this is India, the third one. Second one is China, and the last one is United States. Clearly, we are not competing against the world. So there is an urgent need to find talent. I strongly believe that talent needs to come first before anything else needs to materialize. Once the right research talent comes in here, it will train the right students. When the right students get trained, they will take the engineering jobs, they will start the startups, and the ecosystem would flourish. But at this present moment in time, we are sort of losing the battle with respect to the fast moving pace in the world, and the more we delay ourselves, the more it is going to become hard for us to catch up. And given that IT is one very important part of our financial success, it really is important that we put some efforts into AI. I think I was asked to spend 20 to 30 minutes giving you a talk, and I have very happily spent 1 hour. So this is my last slide. Thank you for laughing once in a while. So AI is definitely in a hype cycle. There is no question about it. It is extremely hyped. Everybody is talking about it all the time. Pretty much every day there are new articles that are coming out. Definitely AI is overhyped. But some people also believed that this hype is sort of meant to stay a little bit. So some people believe that AI is overhyped. In other words, in the previous times when there was an AI hype, people were claiming we can do lots of things, but no real successes had been demonstrated. This is the first time where people are claiming to do lots of things, of course, again, but some valuable and difficult successes have also been demonstrated. So this time we cannot argue that AI is just claiming and not delivering. I do believe that there will be an AI winter rather soon, maybe in 5 years, but it is not clear how bad that winter is going to be. At some point we are going to plateau, every technology plateaus, and again you have to think of and you have to find new technology that will take us off that plateau, but this plateau is not going to be that bad. This plateau is not going to be that all the funding goes away. This is my belief. I think AI is here to stay. As an individual, as a society, as a nation, the best we can do is to respond to this AI growth. If you can jump on this bandwagon, I would say learn about it, help in contributing to its success. As a nation, bring in the right people, build a country which is ready to take care of this new future that is imminent and could come in about 10 to 15 years from now. I am going to stop here. Thank you very much.